Excuse me. How are you doing, Ania?
I'm good. How are you?
Fine. We'll be starting in a few minutes.
Okay.
Since we'll be starting in a few minutes, do you have any question for me before we start?
No questions.
Good. Good. Very good. Yeah. Miss Bennett, how are you? Miss Bennett today? Miss Bennett? Can you hear me? I think it's maybe her speaker is off.
Sorry about that. My mic wasn't working. Can you hear me?
Yeah, I can hear you now.
Hey,
So I probably I can guarantee you that by Saturday night your this thing will be ready. So that I can make it 1 week for you. So it will be due next week. The test. Okay.
I'm sorry, I heard you, but I think something was going on with Zoom.
I know. So I'm talking to Aaron now. I'll come to you in a minute.
Okay.
Mr. Aaron, can you hear me now?
Yeah.
I haven't done it yet, but it's a busy week. But I will tomorrow. I can actually probably do it immediately after this class. But let's just check it tomorrow night to be there. So I will just like the other members. I'll make it to be due the following week. Okay.
All right.
I'm talking about the test one. Now, Miss Bennett,
yes.
yours as well. Those ones that you missed, I will look at your grade book, see the ones that you missed.
Okay, I think I only missed the test. The one that was.
You only missed the test?
Yes, that's the only one I missed.
But did you have the account before the 2 weeks passed? Remember, you have access. Then after the 2 weeks, you won't have access anymore until you put it, So
wait, can you repeat that? I didn't hear you.
There's an account. You have the free access for 2 weeks.
I used that already, and then I just paid for it a few days ago.
So that means you have access during that first 2 weeks when it is here. Everybody, it is free. Then after that, you are locked out, right?
Right.
Then you're back in. Okay. So that means that for you and Aaron, I'll put it there.
Okay.
Yeah. So, Miss Ania, before we start again, do you remember anything to ask me?
No.
Okay, let's begin then. So last on Wednesday, I showed you guys some of the basic probability rules, and we actually did some examples on those rules. Those rules, not all of them, but we did a classical probability. We are still on classical probability. Why stating these rules? Now, one of the rules that we didn't cover is the complementary rule. Group of complement. Well, two events are complement of each other. Where when if one event occurs, it prevents the other one from occurring. For example, your complement of being in class now is not being in class. See, your complement of me sitting down is me standing up. Yeah. So I mean, when I say the complement, the event complement of that, and we use this symbol to represent the complement. It can be any letter. It can be E or A. It doesn't matter. E, C. Some books use it in this form, which means E complement. See? So, and some books do it, write it in this form. E prime. Like I say, you can use E or A for the event, it doesn't matter. E prime also means E complement. So based on this explanation, you can look at this example that we have here. Let me make them big. So like again, the complement is when the event is a complement of the other event. That means when one of them occur, they cannot occur at the same time. This complement of you buying a lottery ticket is you're not buying a lottery ticket. So let us answer a few questions on complement. So solution for these questions. It says find the complement of each event. But A says rolling the dice and getting a 4. You know, a dice has 6 sides, and each of them have numbers. Side 1 have number 1, side 2 have the number 2, and so on and so forth. Says all the way to the 6th side of the dice, and you can see the sides. So rolling the dice and getting a 4. The complement means not getting a 4. A 4, which means getting, okay, getting 1, 2, 3, 5, and 6. That's the complement of getting a 4. See? So at B says selecting a letter of the alphabet and getting a vowel. Now I think we have 5 vowels in English language. 5 vowels. A, E, I, O, U. Am I right or wrong?
Right.
Yes. So
Right.
getting a vowel, the complement means getting a consonant. Getting not getting a vowel. Yeah, not getting a vowel. A vowel. And this includes getting you have, of course, getting B, because you can't put A. The vowels are A, E, I, O, U. So not getting a vowel means getting B, C, D, F, G, H, J, K. I should put them in a brace bracket. L, M, N, P, Q, R, S, T, V, W, X, Y, and Z. See, that means we call this word consonants. Now, so that means that gives you an idea of what a complement is. The rest of this you can figure them out. For example, say selecting a month and getting a month that begins with J. It means getting month that does not begin with J. Then you can list that one out by yourself. Any question on that? Any question?
No.
Now, to solve problem, look at the complement rule. Complement rule. Okay. It says the probability of E complement E complement or A complement, if you like, as the case may be, if you like, will be okay, is equals 1 minus probability of E. And we use it a lot when we are solving the probability of something like the probability of at least, if you ask the question, what is the probability of getting at least something, we'll come to that eventually. But let us try one example where we use this rule. It says probability of A complement What happened? I think. Okay. Give me 1 minute. I want to check something. Okay. Yeah. You guys can see the screen. Am I right?
Yeah.
Okay. I just want something just pop up. Then I thought I lost you. Okay. All right. Now, let us solve this example that involves complement rule. Okay. Now it says here in a lottery game. In a lottery game, each player chooses to a 3-digit number between 000 and 999. A player wins if his or her 3-digit number is chosen. Find the probability that a player buying a single ticket wins the game. Okay. Find the probability that a player buying a single ticket wins the game. Let us say that W is for win, and W complement loses. Player loses. Excuse me. Okay. Now, say we are looking for the probability that a player buying a single ticket loses the game. Win is that he wins. Is the event that he wins. The opposite, which is a complement, means that he loses the game. So to answer this, let us find the probability that the person wins the game. Now remember, this is from 000 to 999. That means we got a number like 001. The first one is 000. The second one is 001. See, like let me put it this way: 000. First number, just like pick 3 lottery. It has 001, 002, all the way to the last one, which is like 999. So you have the sample space as 1,000 slots. And this is the example of a classical probability that we did yesterday, on Wednesday, because we know the sample space from 000 to 999, which is 1,000. So now, finding the probability that he wins, for the player to win, for classical probability, we use sample space. Number of possible ways they can win, and the number of possible, then divided by the sample space. Okay, so the probability that he wins, that's W. Okay, I'll make it this thing big. I don't know why it keeps changing back to. So the probability that he wins is, now he buys for the single ticket, going to be 1 out of 1,000. See, because this is our sample space. So that sample space equals 1,000 possibilities. So if you divide this using decimals, or I can divide it on off head, because this is division by powers of 10, we call it. So 1 divided by 1,000, it will give us the answer in scientific form. Okay, it didn't. 0.001. So not even up to 1%. Okay. 0.001, which is 0.001. See, you can see why most people lose. The game is usually rigged in favor of the house. It's always on the house. If you win, you are just lucky. Anyway, you get the point now. Wow. So the complement is the probability of losing again. So this is probability of winning, which is not like 0.1% chance of winning. Now, probability of losing is probability of the complement, W complement. So now we apply this formula you have here, which is you have 1 minus probability of winning, okay, which is 1 minus 0.001, which is if you subtract this using decimals, 1 minus 1 minus 0.001, 0.999, which means that you have 999. You have 99.9% chance of losing. 99.9% of losing. So I don't want to discourage you from buying lottery tickets, because you never know. You can be lucky. You can be the lucky one. People win it, but the chance of winning it is very slim. Anyway, we can now see how we can use complement. Yeah. Okay. So, any question before we continue?
No question.
So now we can look at the other type of probability, the one we call empirical probability. Now, under empirical probability, we calculate probability of events based on the sample space. We don't know the sample space, so we have to calculate the sample space or estimate it by ourselves. Yeah, that's why we call it empirical probability, or you can also call it relative frequency probability. Now, based on what I have just said, I can now give you the formula for empirical probability. I will take you to the other. I think I opened too many pages, so I'm gonna remove some of them. Okay, let me take away some of them. Okay, good. And I think, oh yeah, then this one should go. Okay. All right. Now, this is what I'm sharing now. So I can write the formula for empirical probability here. Okay. So that because we have to estimate the probability ourselves, we're going to use this formula to figure it out, and the formula will be the probability of event E will be equals frequency of event E, frequency of event E divided by the total frequency. Yeah. So that is how the formula we use for empirical probability. Frequency of event E divided by the total frequency. Yeah. It's gonna be right here. That's the formula right there. Divided by the total frequency. Okay. Okay, that's it. Now, how do we use it? I'll give you two examples. Maybe we can even use one example. Let's use one example here, or probably two would be good. Let's use two. So the first one we're going to do is this one. It says, when Mendel conducted his famous experiment in genetics using peas. You know, Gregor Mendel is the father of genetics. I mean, according to science. Anyway, it says here that one sample of offspring consisted of 428 green peas and 152 yellow peas. Based on these results, estimate the probability of getting an offspring pea that is green. Now, is this result reasonably close to the value of 3/4 that was expected? So again, here we don't know the sample space. So we have to put the sample space, calculate it ourselves. So let's say that G for green, okay, green peas, and green peas, and Y for yellow peas. Okay, now A says estimate the probability of getting an offspring pea that is green. So to do that, we need to get the sample space. G will have excuse me, 428 peas. And for yellow peas, yellow, I will have give us 152 yellow peas. So that the sample space, which is our total, will now become, okay, you add this to 428 plus 152. So I'll take it then 428 plus 152. Give me 580. That becomes our sample space. 580. Okay. 580. So that we have the probability we're looking for. Says part A now says find the probability that estimate the probability that the offspring or getting an offspring P that is green. Okay. So we have this as you want me to check something. Yeah. Okay. Now the probability of green becomes equal. Now remember the rule, the formula. It's a frequency of E divided by total frequency. The frequency of G is 428. And the total frequency is 580. So that gives us 428 divided by 580. So 428 divided by 580. 0.7379, which basically is, if you round it to 2 decimal places, it means 0.738. 0.738. 0.738. Okay. Or you can call it, if you like, 73.8% chance of getting an offspring P that is green. Now, part B says, is this result reasonably close to 3/4 that was expected? Let's see. 3/4 means 3/4, which is 0.75. You all know that already. 0.75. You can check it here. In decimals, you can confirm it. 3/4. Okay, 3 divided by 4.75. So 3/4 is very close. The answer we get here is 0.738, which is 0.74. So and then 3/4 is 0.75. So the answer is yes. So you can see in this empirical example, we have to estimate the sample space by ourselves, and then use it to answer the questions we have. or that we are given. Any question from?
No question.
Good, good. So let's try one example on empirical, and then we'll round up. So next week we start from other concepts, things like mutual exclusiveness, dependent events, independent events, and then addition rules. So, or more rules. Probably if you understand the rules, you can easily figure it out. Look at this. It says, hospital records, okay, indicated that the maternity patient stayed in the hospital for a number of days, shown below. Find the following probabilities that the patient stays exactly 5 days. A patient stayed less than 6 days. A patient stayed at most 4 days. A patient stayed at least 5 days. So now, excuse me, we don't know the sample space. That means we have to figure it out by ourselves. So how do we do that? We copy this table. Solution. Okay. All right. So we're gonna find the total. That will be our total. Will be our sample space. Total of this be our sample. So let me write it down. And then we can add them up. We got 15, 32, 15 plus 32 plus 56 plus 19 plus 5. 1 plus 32. So let's add this up. So you have 15 plus 32 plus 56 plus 19 plus 5, 127. So that becomes our sample space. 127. Okay. Now we're ready to work. What it says, a patient find this probably a patient stay exactly 5 days. Remembering the formula, which says frequency of event E divided by frequency of divided by total frequency. So look at for event 3, you see the frequency right here. For event 4, you see the frequency. For 5, frequency. So it says a patient stay exactly 5 days. That's A. Probability of five patients staying 5 days. Okay. Patients staying 5 days. Okay. Equals, see, the frequency here for 5 days is 56. So you're gonna be 56. What about 157? So that's to give us the probability we are looking for. 56 divided by 127. 56 divided by 127. 0.440999, 0944, and so on. So usually 3 decimal places is good enough. You have 0.441. 0.441. 0.441. Okay. You see how simple this is. You have to understand the rule. Once you understand the rule and follow it, it should be fine. B part says a patient stayed less than 6 days. This is 6 days right here. And 5, 4, 3 less than 6 days. So less than 6 days does not include 6 days, the 6th day. So that probability of the patient stayed less than 6 days. 6 days equals probability of 3 days plus probability of 4 days plus probability of 5 days. Okay, which give us have it in this form. Let me write them down and then I can put them in. But you know that for 5 days, 3 days is 15 out of 127. Which is 15. I'm going to put them in parentheses for it. So 15 of 127. Okay. Plus for 4 days, it is 32 out of 127. 32 out of 127. For 5 days, it is 56 out of 127. Out of 127. So when we put all this together and check it in decimals, let me write it down again. 15 for 127 plus 32 for 127 plus 56 for 127. Okay, I'm taking it to decimals to figure this out. We got 15 over 127. Okay. Plus 32 by 127. Okay. And plus 56 divided by 127. 0.811. So 0.811. Okay. 0.811. So I'll take it back there. 0.811. Now, you see, so it's all about the rules. Now, part 6 says a patient stayed at most 4 days. At most 4 days means 4 days or less. So at 6 says probability of patient stayed at most 4 days. Like I said, at most 4 days means 4 days or less. I mean, it's probability of 3 and 4. It's probability of 3 days plus probability of 4 days. Okay. For 3 days, we have equals 15 over 127. 15 divided by 127. Okay, plus we have 32 over 127. 32 divided by 127. And I'll give you the probability that it say at most 4 days. So I'm gonna figure it out using decimals. We have 52 over 15 over 127. Excuse me. I'll just erase one of them because we have this here already. 0.370. 0.370. 0.370. Any questions? Any questions, class?
No questions.
No, no question.
Let's do the last one, which says the patient stay at least 5 days. At least 5 days means 5 days or more. So part C says, sorry, part D says the patient stayed at least 5 days. So like I say, it means 5 days or more. 5 days or more. So that's gonna be the probability of 5 days, 6 days, and 7 days. This probability of 5 days plus probability of 6 days plus probability of 7 days, which give us for 5 days. 5 days we have 56 over 127. 56 over 127. For 6 days we have 19 over 127. Now for 7 days we have 5 over 127. I'll give you the answer. Write it down. So you got 56 127 plus 19 127 plus 5 127. So you have it here in decimals. So 56 over 127, okay, plus 19 over 127 plus 5 over 127. So I get 0.69, 0.6299, it continues. So usually two decimal places west. I'm sorry, 3 decimal places best. So 0.630 answer. 0.630. Okay. 0.630. Okay. Now, let me take your attendance, and if you don't have any question, then feel free to leave. After I take your name, I have who do I have here? I got, excuse me, names. Okay, I have Aaron, Ania, and Bennett. Ania, Aaron, and Bennett. Okay. All right. Now, if you don't have any question, feel free to leave, and I'll see you on Monday. Mr. Bennett and Aaron, expect to have your test ready tomorrow evening. Okay.
Okay, sounds good.
Have a good weekend.
You have a good weekend.
Have a good one.
You too.